Starting with the first section, we're going to factor out the greatest common factor. For the sake of time, in the first two examples, you'll see that I took each term and I broke them down into factors. My goal here is to identify what is the same in both the first and the second factor. I can take a 4, a 3, and 2 W's. What I take from each one becomes my GCF. What I have left over goes on the inside. I have a 3 left. Moving to the next example, what I have the same are 3's and an x. Gives me a GCF of 3x. What I'm left with in the front is a 7 minus 3, and then notice I have 5 x's. The next example, I have 3 terms. The most number of m's that can come out from every single one the same is going to be 1m. The most number of n's is 2. I can take 2 from here, 2 from here, and 2 from here. Mn squared is my GCF. If I look up here and I think about breaking this down, if mn squared is what I end up making my GCF, that leaves me with a 1 here, minus 12. I have 2 m's left and 2 n's left, plus 35, 4 m's, and an n. The next section is factoring into 2 binomials. This only happens when I have trinomials that factor, where I have a 1 in front, or in the case of difference of squares, where the first term and the second are both perfect squares separated by a minus sign. In number 4, we start with our setup. So my setup here is going to be a p and a p. I then look at the end and say, how do I get a positive for the last? Plus, plus, minus, minus. What I choose is based on the middle sign. So this is plus, plus. What 2 numbers multiply to give me 36, but add to give me 12? In this case, it's going to be 6 and 6. Next example starts with setup, m times m. I then can look at signs. So to get a negative in the end, I either have to have negative positive or positive negative. Since this is a positive is the middle, this is my order. What 2 numbers multiply to give me 80, but activate to the number 2? That's 10 and 8. 10 goes first, followed by the 8. In example 6, there's only 2 terms. Notice I put a star by this one. Y times y is a perfect square. 9 times 9 is a perfect square. We write the y's in front. Automatically have opposite signs. And then we fill in with the perfect squares at the end. Notice I don't have sign rules. They're opposite signs when it's difference of squares. Number 7, x and x, setup. The plus at the end tells me it's either plus plus or minus minus. Turns out it's minus minus because the second sign is a negative. What 2 numbers multiply to give me 16, but activate to the number 10? That's going to be an 8 and a 2. Number 8 only has 2 terms, both of which are perfect squares. 4 is 2 and 2, w squared, ww, 5 and 5. 2w and 2w, perfect squares that make 4w squared. Opposite signs, perfect square, 5 and 5. Let's take a second on this right-hand side and list out all of the perfect squares. So those numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. We also include x squared, y squared, etc. In number 9, 3 terms gives me the regular factoring, n times n. This sign is a negative. To get that, I either have to have opposite signs. Which pair I choose is based on the leading middle term, plus minus. What two numbers multiply to give me 32, but then activate to 4? And the answers are 8 and 4. 10's a little bit harder. Setup. Signs. Now I have to figure out what two numbers multiply to give me 66, but then go give me 25 when I combine them. Those numbers are big. This will not be on a test like this, but the answer is going to be 22 and 3. X and X. Minus because of the negative here. And 4. And the last one, M, N. 7 and 7. These are our basic skills. Factoring out GCF, difference of squares, and trinomial factoring. 3 terms that end up going into 2 parenthesis sets. As I move to the bottom, factor completely just means that I'm going to have to do the process of factoring twice in every problem. I'm going to use 2 different types. So when I look at the first one, I have 3 terms. I don't have 1x squared, so that's what I need in order to factor into the smaller parenthesis groups. I'm going to use GCF factoring. My GCF in this number is going to be a 9. 9 times what? X squared gives me 9x squared. 9 times 4x gives me 36x. 9 times 3 gives me 27. These 3 that are left, if this was an original problem, you would tell me you could factor this. 1, 2. You would say x and x. You would look at your signs. So this plus gives me plus plus, minus minus, plus plus. And my numbers end up being 3 and 1. If this were a test, you would lose 1 point because you forgot to bring down the 9. So please don't forget to bring down the 9 when you do your final answer. Same thing again, we'll take a 2 out front. When we factor out the 2, we get z squared minus 17z plus 60. From here, I would create baby parentheses. My 3 terms are going to factor into a z and a z. My signs are plus plus, minus minus. Because of this, it's minus minus. My numbers are 15 and 4. 12 and 5. Don't forget to bring down the 2. The next one, my GCF, is very simply a 3 and a y. In order to factor, I need y squared, y, and a number. This is going to leave me with y squared minus y minus 20. This will continue to factor into y and y. In order to have a negative in the end, I need opposite signs. I'm going to choose negative positive to match the middle sign. negative, and then positive. 5 and 4, bring down the 3y. Next one, GCF is going to be a 5. Leaves me with x squared minus 9. This is two terms and they're both perfect squares, so this is difference of squares factoring. X, x, opposite signs automatically. 3 and 3 give me 9. Don't forget to bring down the 5. All done. The very last skill is simplifying fractions. The tops and the bottoms will be made up of problems that you can break down using either GCF or factoring. The top, 3 terms, x and x, so it's either plus plus or minus minus, 9 and 1. The bottom is x minus 1. We then can cancel what's the same, and my final answer is x minus 9. Next one, x and x, same thing. This negative tells me it's either negative, positive, positive, negative. 4 and 3. The bottom, however, notice here, is difference of squares. X and x, plus minus, 4 and 4. What can I cancel? X plus 4, x plus 4. I am not allowed to cancel these x's. This is a group x minus 3. This is a group x minus 4. If I want to cancel them, I have to cancel the whole group. This is my final answer. Last one, number 19. This is just a double problem of factoring. X, x, plus plus, minus minus, plus plus, 6 and 5. Here we go, x, x, plus minus, minus plus, plus minus, 6 and 4. These are the same, they're puzzles, they fit together, they cancel. What I'm left with is that.